So now, when we talk about the addition, subtraction, all these things, we talked about different types of vectors also, correct? Now, see, in this, suppose let's say on x-axis and on y-axis. See, let's say we are moving only in the x-axis, okay? Now, let's call that as a1, okay? And then, see, we are moving on the y-axis, call that as a2. Now, there are two vectors, a1 and a2, right? Now, okay, see, imagine like this. Let's say you are moving in the east direction, and let's say you want to move in the north direction also. North and east, both the directions if you move it, then you will move in the northeast direction, correct? So, basically, the other way around if I tell, that is, if you are moving in the northeast direction, then you are moving in north plus you are moving in east, correct? Now, this is what we call as resolving a vector. See, resolve meaning to split it into parts. Okay, so to split it into parts. Now, in this case, we had vector a1 and vector a2, correct? So we can say that a1 and a2 are the resolved vectors of vector a. See, this is vector a. So vector a is getting resolved into a1 and a2. Okay, understood, right? So this is what we call as resolving a vector. Resolving a vector plays a very important part. Now see, once the vector gets resolved, it will have two components, correct? So I can say a1 and a2 are two components. Now a1 is in x-axis, a2 is in y-axis, correct? Alright. So we can say a1 is equal to ax into I cap and a2 is basically ay into j cap. Now ax and ay is fine, but what is that I and j? See, this I and j, these are what we call as unit vectors. Okay, unit vectors. This is one more type of vector. Now unit vectors we are going to use everywhere from now on. See, when we say unit vector, so it's basically the magnitude is 1 and the direction depends on what axis. Okay, for example, if you write vector A is equal to mod of A into A cap. Now that mod of A is the magnitude, A cap is the direction. Understood? So remember this, any vector has a magnitude and direction, right? That's why we write it this way. Now that A cap is nothing but vector A by mod of A. Correct? Now when you say unit vector, see, unit meaning what? The magnitude has to be 1. Correct? So when you write I cap represents that it is moving in the x-axis direction. Okay? Like I don't have to tell that I am moving 12 kilometers in east and 15 kilometers in north. For example, let's say I tell that I cap is in east and j cap is in north. So I don't have to tell that 12 kilometers east. I can just say 12I or 12 kilometer I. That means 12 kilometers, when that I comes, basically it tells us or it's implied that you are moving in that particular direction. Now I cap is always associated with x-axis. So when you write ax into I cap, meaning the vector has a magnitude of ax in the x-axis direction. Okay, x-axis direction. Same thing, ay into j cap. J cap is always associated with the y-axis. So ay into j cap, basically it says ay units in the y-axis direction. Okay, see, for example, suppose if I say 3i plus 4j, 3i plus 4j, meaning, see, it's plus 3i and plus 4j, correct? That means positive 3 units you are moving in the x-axis direction and positive 4 units you are moving in the y-axis direction. That is 3i plus 4j. Understood, right? Now, so that means, let's come back to the vectors again. See here, vector A is ax I cap plus ay into j cap. Right? Now see here, in this case, your vector A, see, this particular vector A is making some angle theta with the x-axis, correct? So, see, this basically is ay and this is ax and this is vector a, correct? So, what we can write, see, we can use Pythagoras theorem and all the trigonometric functions to actually calculate this. So, what we'll do is, see, you have ax and you have ay and you have a. So, in this case, what is cos theta? Ax by a, right? And what is sin theta? Ay by a. So, we write ax is equal to a cos theta and ay is equal to a sin theta. Okay? Now, you got these two. Now, take the ratio of this. That is, we'll do ay and divided by ax. You'll get this as a sin theta by a cos theta. You'll get that as tan theta. Right? So, the angle which the vector is making with the x-axis, you can find out using this. So, tan theta is equal to ay by ax. Okay? Now, to find the magnitude, that's basically mod of a, correct? Mod of vector a. So, that is, see, in this, can we not use Pythagoras theorem? If you use Pythagoras theorem, that will give you the hypotenuse, correct? Basically, that's the resultant. So, when you have ax and ay, that's basically a cos theta whole square plus a sin theta whole square. Right? You get a square cos square theta plus a square sin square theta. Take a square common, you get cos square theta plus sin square theta, which is 1. So you will end up with square root of a square, which is a. So, to get the magnitude, you just have to do root of ax square plus ay square. Okay? So this gives you the resultant, the magnitude of the resultant. And for the angle, you have to do tan theta, which is ay by ax. Understood? So this is what we call as resolving of vectors. Alright?